Hi, my name is Ricardo Medina, and this is the solution for the problem situation. In this project, we take a look at voice recognition, specifically at what makes it unique to each person. Since the voice, when recorded into a computer, is basically just a signal, we can use techniques of signal analyzing to determine what makes it unique. Throughout this project, we execute 3 experiments. The first one is just about 2 subjects that record their voices into MATLAB code, and the code employs techniques such as the next ones to analyze the signal: time and frequency domain analysis, histogram, statistical analysis such as mean, variance, standard, skewness, kurtosis, dispersion, CDF, PDF, autocorrelation, Fourier transform, and spectral density. So in the first experiment, just 2 subjects record their voice once, and then we compare the results. Here are the results that we got from this experiment, and what we got from that specific experiment is that the most valuable piece of information is the frequency domain analysis. Also, the autocorrelation and the Fourier transform of the autocorrelation, since the frequency domain analysis tells us which frequencies have more decibels, then we can determine better the signal. The other types of analysis that are more statistical didn't help us much, because the mean and the variance are just only a scalar value, so it's not unique. In the second experiment, what we did was we recorded ourselves 5 times and then made a mean matrix of all the signals that we recorded, so that the experiment would be more dynamic. So here are the results from that one. Here too, we discovered that the graphs of frequency domain analysis were the most valuable ones, since they were the ones that were more similar to the first graphs and had the same type of differences between subjects, like the decibels of a certain frequency or the dispersion of it. Also, of course, the autocorrelation and the Fourier transform of the autocorrelation. And the third and final experiment, we recorded a female voice of a partner of ours to compare with the other ones. And here we can see the differences between the frequency domain graphs from this one to the other ones. Here, since it's a higher pitch voice from a female, it has higher frequency, more noticeable, with more decibels of magnitude. Also, the PDF graph between all of them changed more the amplitude than anything else, but in the more lower ones, the amplitude was higher, and the more higher type of voices, the amplitude was lower. And we noticed something funny here, that the autocorrelation function has 2 dips below the 0 line, and in the lower voices, it only has 1 dip, if one at all, like here. And in conclusion, we get that the most valuable piece of information that we can get is from the frequency domain, either of a autocorrelation function and the frequency domain of just the signal itself, because what makes a voice unique are the subharmonies, which translate to the frequencies that we get, and the decibels that it represents in our voice. That's what it makes the timbre unique. And thank you, that's it.